Welcome to geometry class, students. On Thursday, the 29th, oh my goodness, we got a test tomorrow. I hope you guys are ready for this test. I'm going to go over in a second these terms you need to know. Booyah, booyah, booyah. Okay, we're going to go over that. I'm going to go over some problems with you. This is your review sheet. I gave that to you yesterday. I care about y'all. You know that. I love all the students I teach, and I hope that you'll study and study hard. I hope that you'll trust me that I am not lying to you. This is basic geometry. It is not a track one, fast-paced, moving, super hard class. It might seem hard to you, but believe me, the other class is more difficult. They're going to be covering harder problems and learning more definitions, theorems, and postulates. For example, we had a postulate you learned this week called the midpoint postulate. If B is between A and C, then AC equals AB plus BC. I did not even put that on your things to study for your test. I want you to know the principle and be able to use it mathematically, but I didn't make you memorize that. There's another one, if B lies inside the interior of angle ACD, then angle ACB plus BCD equals ACD, or something like that. I didn't put that on here. I'm trying to keep it to basic postulates, basic definitions and terms, and learn basic geometry, okay? So you will have a test tomorrow. You do not have to do this review sheet, but if you'll do it, you will be given 5 bonus points on your test, but you must turn it in. You must turn it in to the supervising teacher on Friday when you turn your test in, okay? All right, now, I think that's basically it. I came to class a couple times last year for tests, and some of you saw me in the hallway. Don't think that I don't care about you. The reason I've not been able to do that this year is because I don't have my older children at the house. Last year, my son Michael could stay with my younger 3 boys. Now that he's at Berean, I have Jessica at her school, Michael's at his school, and I have a 12, a 10, and a 7-year-old. I just don't feel too comfortable leaving them here by themselves, so I hope that makes sense to you. Here's a word of advice. I would not try to copy all of these terms and definitions down now that I'm putting up here. I would just simply listen, and then you can pause the video and write these down at your own time, or when you get home tonight maybe, if you have internet access, which I hope all of you do. Right now, I would really mainly focus on working the problems out, these right here, 13 through 39. Okay? All right, here we go. Inductive reasoning, conjecture, counterexample, postulates, postulate 1, postulate 2, collinear points, coplanar points. All of this will be on your test. They will all be fill in the blank. Coplanar lines, postulate 3. I don't know why I have postulate 3 on there twice. I guess I liked it so much, There we go. How's that? That's kind of funny. It will be on the test once, not twice. Coplanar lines, postulate 3, postulate 4, congruent segments, angle, definition of congruent angles, definition of acute angle, definition of obtuse angle, definition of right angle, definition of straight angle. So know these terms, postulates, be able to fill in the blank, okay? So you can go back and study those later. Let's get into the math problems now. But that is something that you will need to know for your test tomorrow. There will not be a word bank. Please know those. Okay, numbers 13 and 14, the directions say write the next two, numbers 13, 14, and 15, write the next 2 numbers you would expect in this pattern. Well, 5, 14, 23, 32, it looks like they're adding 9 over and over. Adding 9. So the next number would be 41, and the next number would be 50. All right, moving on to number 14. 6, 18, 54, 162. Well, it looks like to me they're multiplying by 3. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. 162 times 3 would be, let's see, 6, 8. I think it's 486. I did that quickly in my head. And then if you take 486 times 3, you would get, let's see, let me get a look at it. 8 carrier 1, 25 carrier 2, you would get 1,458. So the pattern here is they're multiplying by 3 over and over. And you can use a calculator, of course, if you need to make it faster, but those are the next 2 numbers we would expect to see in that series of numbers. And then here, this is really simple. We're subtracting 10. 100 minus 10, 90 minus 10, 80 minus 10, 70 minus 10 would be 60, and then 50. All right, so let's move on now to numbers 16 and 17. The directions say for 16 and 17, sketch the next figure you expect in the pattern. Well, we have one line here, then the whole thing turned to the right, and it has 2. Now it's pointing up, and it has 3. I would think it would twist again myself, and you would have 4 marks over here. That's what I think, okay? You had 1 mark here, then 2 marks here, then 3 marks up here, so I would think we'd have 4 marks here. All right? Really not any teaching I can do for you, I'm sorry. It's just kind of, look at it, reason, and see if you can figure it out, okay? All right, number 17. We have 1 dot. Now please look at what they did next. See this 1 dot? It looks like they put it in the middle and they put dots around it. Okay, do you see that? Now look what they did. It looks like then they took this whole thing and put it in the middle. See, there it is, right there in the middle. And they put a row of dots around it. So I would think that common sense would tell you the next thing we're going to have would be this whole thing here in the middle, okay, and then a row of dots around it. So I would think we would have this, all of those connected, of course, like that. And then this next row, so same thing. And all of those connected. Beautiful drawing like always. So there, I took all of this whole thing, and I put it right down here. And then you put 1 more row. Remember, you took what was put it in the middle, and then put a row around it. Then you took this, put it in the middle, did a row around it. Now you take this whole thing, put it here, and now put a row around it. So I'll make the points a little bigger so we can see them a little easier. And I probably should have done that with all of these rows, but there we go. And then connect them. Don't get discouraged if you're not as awesome of a drawer as I am. I know that I'm just highly skilled, and you guys are envious of my drawing ability. There we go. That would be the next figure we would expect to see. Okay. Now let's move on and take a look. Your books really should be open, obviously. I mean, you can hear me say the directions, but it would help you if you also read them yourself. Number 18, complete the conjecture based on the pattern you observe. Now look what they did here. When you take 4 times 5 times 6 times 7 plus 1, you get 29 times 29. Do you see that? I'm just reading right there in the book. When you take 5 times 6 times 7 times 8 plus 1, you get 41 times 41. When you take 7 times 8 times 9 times 10 plus 1, you get 71 times 71. So when you take 6 times 7 times 8 times 9 plus 1, you get 55 times 55. So here's the conjecture. Do you see it right there? Underneath number 18, it says conjecture. The product of 4 consecutive integers, like 4, 5, 6, 7, plus 1 is always a blank number. Well, it looks like every single one of them was giving you out something like this. 29 times 29, 41 times 41, 71 times 71, 55 times 55. So how would I fill in that conjecture blank? I would say the product of 4 consecutive numbers plus 1 is always a squared number. It's always a squared number. You get out 29 times 29, or 41 times 41, or 71 times 71, or 55 times 55. That's not a very easy problem to see. This is probably the hardest one we've done yet so far. But that is the answer. All right. Not a lot I can say on that. Just look at the pattern there, and you can see how the numbers are coming out to 29 times 29, or 41 times 41, etc., which would be numbers squared. All right, number 19. Show that the conjecture is false by giving a counterexample. Okay, here's the conjecture. the cube of a number. That means when you take a number like 5 and you cube it, okay? The cube of a number is always greater than the number you started with, okay? 5 cubed gives you what? 125. Is 125 greater than 5? Yep. Looks good so far. Let's try 2. What's 2 cubed? 8. Man, it looks good so far. 8's bigger than 2. This conjecture might be true. I hope I can find a counterexample. How about 4? Well, that's not going to work. 4 times 4 times 4 is 64, and 64 is bigger than 4. Let's try 1. What's 1 times 1 times 1? 1 to the third power. Uh-oh, 1 times 1 times 1 is 1. Is 1 greater than 1? Is this number here greater than this number? No, it is not. So there's your there's your counterexample right there. That's a counterexample. This example proves your conjecture wrong. Your conjecture said whenever you take a number, like 5 for example, and you cube it, the number you get out will always be greater than the number you started with. And that looks pretty good for a while until we came to this one right here. That's called a counterexample. All right, let's go ahead and move on to number 20. Slide this up, and actually 20 through 23, excuse me. Let's take a look at numbers 20 through 23. Use the diagram at the right, which is this diagram right here, students. This one right here. Use the diagram at the right to decide whether the statement is true or false. Okay, number 20. Point A lies on line M. Well, here's M, so that's referring to, let me get a different color ink so we can see it better. Not green, that's for sure. All right, here's M, so this is line M right here. Does point A lie on line M? Sure does, looks good to me. Right there it is. Now, does point A also lie on this line here? Sure it does, but it also lies on point M. Point E lies on M. Well, here's line M, and here's point E. Does point E lie on this line down here? Absolutely not. So it is, I mean, I can't even count. Your math teacher cannot count. That's sad. All right, 20 is T. All right, what's going on here? 20 is T, 21 is false. All right, 22. Points B, C, and D are collinear. That means they all lie on the same line. So here's B, C, and D. Now B and D lie on the same line, but C does not lie on that line. So those 3 points are not collinear, so 22 would be false. And then 23, draw 4 points. Oh, I had 20 through 23, didn't I? It should be 20 through 22. 23 is totally different. 23 is draw 4 points, no 3 of which are collinear. Okay, this will be rich. Here we go. All right, let's go ahead and get a blank screen up here. Number 23. Draw these 4 points so that no 3 are collinear. That's pretty easy. Put a J here, and then I'll put a K here, and then I'll put an L here, I guess, and then an M over here. None of those 3 points are collinear, okay? These 2 are, these 2, but no 3 are collinear. All right, let's continue on. Sketch LK. So here's, is that ray LK? No, segment. Here's segment LK. So sketch segment LK like that, and add a point N on that segment. So I'm going to put an N right there. All right. Then it says sketch ray NJ. So start from N and go. That's a very poor line. Start from N and go to J. Put 1 arrow on the end. There's ray NJ, and then draw ray NM. So here's N and M. There we go. That's all they wanted you to do. Just a little art class, okay? All right, numbers 24 through 27. Use the figure to fill in the blank. And here's my figure right over here. Let's slide it over just a hair to give us a little room to work. And here we go. Number 24. What do they want us to do? Let's see. TU and VU intersect at what point? So here's TU. and here's VU. It looks like they intersect right there at point U to me. So point U. All right, how about 25? Plane PQR. I'm going to highlight it for you. Here's PQR. So this plane right here on the side. Plane PQR and plane UVS. Here's U down to V and over at S. So it's this plane right here. These two planes intersect each other at, well, look, guys, this plane and this plane hit right here, right there. So they hit at line QS, right here, right here. So line QS. Now, I'm not going to argue with you if you said, Mr. Earhart, that's segment QS, because it stops here and it stops here. I think they're assuming the planes go on and on, but I would accept that. It's fine. I'm not going to split hairs with you there. Line QS or segment QS is fine. All right, moving on to number 26. Plane RSV. Let me go ahead and highlight that for you. So R, then S, and then V. Now, how are we going to do that? Oh, here it is, right here. RSV. So that's this bottom plane here. And plane QUV. So here's Q, U, down to V. So it looks like to me we're dealing with this bottom side here. There's one plane. And then this front side here, it looks like to me they intersect at that line right there. I'm going to darken it with black. Looks like they intersect right there. That's one edge or one line those two planes have in common. So they intersect at line VS. Now, if you want to call it segment VS, I'm not going to argue with you. I'm going to say line VS. All right? And that's number 26. Let's take a look at number 27. Plane QSV. Plane QS and then over to V. And then back up again. So QSV, QVS, whatever. QSV and plane TUV. So T to U to V and then back over again. Well, guys, it looks like we're dealing with the front of the box. That was really good. Looks like we're dealing with the front of the box right here. And then the left of the box right there. So that edge is where they intersect right there. And so those two planes would intersect at line UV. Line UV. All right, hope that makes sense. 28 and 29, I'm definitely putting myself on the spot trying to draw. If you can't draw these, do the best you can and go on. I won't put any of these on the test, but let's see if we can't do it. Draw two lanes that are not coplanar and do not intersect. Wow, that's going to be fun, isn't it? I guess we'll draw a line that's going like this, and then another line. Not coplanar, so I guess we would draw it like coming out at us like this, maybe like underneath this line, but they're not intersecting, maybe something like that, possibly. I don't know. That's the best I can do, but imagine two pencils. Hold on a second. There we go. Imagine two pencils, like one's laying across and then one's going up and down but not touching the other pencil, something like that. I know it's important to draw these. Don't think that I'm belittling it, but I know that some people like myself just really struggle with drawing, so the main thing is to visualize it and hopefully be able to see that in your head. 29, a plane and two lines that intersect at one point. That's going to be pretty much hard for me to draw. I'll do the best I can. It'd be something like a plane going back like that. Let's see, then I guess you would have a line came down and hit right here and then kept going through like that, and then a line that hit there and then continued continued out like that. So it's like a piece of paper with a hole, and a pencil goes in diagonal, and a pencil goes in diagonal at the same place. That's kind of what they're getting at, okay? But again, visualize it. Hopefully you can do that, and we're going to move on, okay? All right, we're looking at numbers 30 through 30 and 31. Find the length. Now for number 30, we're trying to find the length of AC. That would be this entire length. Well, look, AB is 10, BC is 37, so the whole length would have to be 10 plus 37, so the length of AC equals 47. Not too difficult. Number 31, they want us to find the length of RS. RS. Well, that's that little segment right there. Now look, students, if the whole segment all the way across is 50, which is what I have right here, it's 50, and this part here is 24, then what would you have to put right here to make 24 plus something give you 50? Wouldn't it be 26? Sure it would be. 24 plus 26 makes the whole length 50. So the length of RS is 26. Now, Mr. Earhart, how'd you get that? Well, take the whole length, which is 50. That's the whole length. And subtract out this segment here. Subtract out 24. And if you do that, you're left over with 26, which is the length of RS. All right, number 32. Plot the points and then decide whether PQ and QR are congruent. So for number 32, point P is over 2 and up 3. So there's a point. I'll put a P right there. Point Q is 2, negative 5. So 2, 1, 2, 3, 4, 5. So that should be point Q. And then point R is 9, negative 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're out here and then down 5. 1, 2, 3, 4, 5. So right there, that would be point R. Okay, now here's what they're asking. Are PQ and QR congruent? So here's PQ right here. If we're going to do it, let's do it right. All right, so here's PQ right here. And here's QR right here. Well, let's see if they're congruent. Count the spaces. Start here and go down. I got 1 space, 2, 3, 4, 5, 6, 7, 8. So it has a length of 8 spaces. Now let's count this one. And by the way, there would be 1 mark right there. We have 1, 2 spaces, another space. That's 4 spaces. Here's 5, 6, 7. And so this segment here has a measurement of 8. This segment here has a measurement of 7. So are these two segments congruent? Well, no. In order for segments to be congruent, they have to have the same measurement, the same length. Let's take a look at number 33. Point negative 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So there's point P, negative 5, 4. Q is 1, 4, so over 1 and up 4. That would be point Q. And then point R is 1, negative 2. So 1 and then negative 2. And that would be point R. Okay, again, we're going to see if PQ is congruent to QR. So here's PQ right there. And I think it would be wise if we redid that and did that. And now we'll try it again. Here's PQ right there. And then here's QR right here. All right, let's count the spaces. I have 1 space, another one, that's 3, then 4, then 5, then 6. So the length of PQ is 6 units. Now let's count down. 1 space, 2, another one, 4, 5, 6. So 6. So yes, these two segments are congruent. They're congruent because they have the same length. Let's take a look at number 34. We're not going to worry about measuring it. Not today. I told you guys to get your protractors and compasses in this weekend. In fact, I'm going to go ahead and say now, starting next week, if you don't have a protractor or a compass, then that is your own fault, okay? You're going to be left behind to scramble because you need to have those starting next week. But I'm not going to make you measure this, but I do want you to label it. It's obviously smaller than 90, and this would be an acute angle. Number 35, I know it's not exactly perfect, but we're going to assume there is a little mark here. This is a right angle. It's 90 degrees, a right angle. Number 36, notice how wide this thing is opened. It is bigger than 90, and we call this an obtuse angle. An obtuse angle. All right, number 37. Now, they want us to find the measurement of angle DEF. So here's D, going down to E, and then all the way over to F. Now think about it. This angle here and this angle here, make up this entire big angle. So if I take this angle here, 60, plus this angle here, 45, and add them together, I will have the measurement of this whole angle right here. And that would be 105 degrees. If you add correctly, 105 degrees. All right, let's take a look at number 38. Now, number 38, they want us to find the measurement of angle HJL. HJL equals blank. Well, here's H, then over to J, then down to L. Okay, they want us to find this little angle right here. Now, students, think about it. We know what the whole angle is. We do, Mr. Earhart. Yeah, it's a right angle. Look in your book. You'll see a right angle symbol. So we know the whole big angle is 90. And then we know this little angle here is 40. So what would this angle right here have to be so that when you add these two angles together, you get 90? Well, obviously, it's got to be 50. And if you don't know how I did that, I took 90, which is the measurement of the whole big angle, and I subtracted out 40, and that left me with 50. So the measurement of angle HJL is 50 degrees. And last but not least, the last problem, notice here, well, first of all, they want us to find the measurement of angle QNM. So QNM equals blank. Now, please look, students. This is what we call, I know my drawing's not perfect, but it is okay to assume that we have a straight line here. Thus, we have a straight angle. Now, remember, straight angles always equal 180 degrees. Please don't forget that. So, I should not have done that. Let me go back. So, with that in mind, straight angles always equal 180. So with that in mind, what angle would I put here, question mark, so that when I take this angle here, 110, and add this angle to it here, it gives me 180 for the whole entire angle all the way across. Well, I mean, you can do it in your head or you can subtract. It's going to be 70 because 110 plus 70 gives you a whole angle of 180 degrees. Another way that I did that is I took the whole angle 180 and I subtracted out 110, which is this angle here, and you're left over with 70. This has been a pretty simple short review sheet. If you finish in class today, or if you finished it last night, maybe whatever, before Thursday even got here, please do not disturb class. Find something to do. Be thankful you have a little bit of extra free time, and maybe some of you are still working the whole class hour. Nonetheless, really be ready for your test tomorrow. Call me or email me if you have any questions.